Hello everyone, welcome back to the channel. My name is Teacher Samuel, and today we're gonna take a look at a number puzzle problem. Now, this kind of problem is a very common type of problem in the Primary 4 SASMO exam. So without further ado, let's take a look at our question. In the following, all the different letters stand for different digits. So, if y is equal to 2, can w also equal to 2? No, because all the different letters stand for different digits. A very important condition we should keep in mind. Now, what is the smallest possible value of the 4-digit number YWVZ? So, the important condition here is smallest possible value, which we also have to pay attention to. Now, the first step to solving this is we analyze which part of the puzzle we should analyze first. So let's move the puzzle to the top left of the screen so that we have more space to do this. Now, I would like to ask you where you think it would be the easiest to start our analysis of this number puzzle problem. If you said the thousands digit, then congratulations, I would agree with you. Now, why is the thousands digit the easiest place to start? Because we know for sure that the thousands digit of y is equal to 1. Now, how do we know this for sure? Because YWVZ is a 4-digit number, and the thousands digit of this number, below it there are no other numbers. So we know for sure that the thousands digit can only be 1, and that there's borrowing from the thousands to the hundreds digit. So let's put on our puzzle marks for every y that it is equal to 1. And we can put a mark on top of the thousands digit to indicate borrowing to the hundreds digit. Now let's continue. And where should we continue next? If you said the hundreds digit, then I would agree with you. Now why the hundreds digit next? Because we have the same letter W repeated in the hundreds digit. So it might be easier to continue there. Now what are the two situations we could have regarding the hundreds digit? We could have no borrowing to the tens digit, or we could have borrowing to the tens digit. So let's consider no borrowing first. How would we express this situation for the hundreds digit in an equation? Well, we could have 10 plus w minus w equals w. The 10 representing borrowing from thousands to hundreds. Now in this situation, what would w be equal to? It would be equal to 10. But is that possible? No. Why? Because w must represent only one digit. So, no borrowing situation is not possible. Now let's consider the borrowing situation. In this situation, what would the equation be? 10 minus 1 plus w minus w equals w. The minus 1 representing the borrowing to the tens. Now in this case, what would w be equal to? It would be 9. And can we get a w of 9? Yes, it is possible, and so we found our w. So we can mark that on our number puzzle. And also mark on the hundreds digit that it borrows over to the tens. Now where should we continue our analysis? If you said ones digit, I would agree. Why the ones digit? Because as you see, we have specific numbers. W is 9 and y is 1. So it's easier to analyze there. We just have z to figure out, and we know that z minus 9 gets the digit of 1. Now if we know that, then can we tell for sure what z is equal to? Yes, z must equal to 0, since 10 minus 9 is 1. And therefore we have borrowing from tens to the ones digit. So let's mark on the puzzle, z is 0 and borrowing from tens to ones. Now we're just left with the tens digit to analyze. Now, we already know there's borrowing from the hundreds digit to the tens digit and from the tens digit to the ones digit. So, how could we express all of this in an equation? Well, it would be 10 minus 1 plus v minus x equals x. And we can simplify this further. 10 minus 1 simplifies to 9, and the minus x we can move to the other side of the equal sign to get 9 plus v equals x plus x. Now, I want to ask you a very important question. Between V and X, which letter should we analyze first? If you said V, then very good job! Excellent! You remembered the condition that we are trying to find the smallest possible YWVZ. So we should analyze V first from the smallest possible digit, which is 0. But can V equal 0? No, because Z is already 0. What about V is 1? Also no, because Y is already 1. So let's try from V equals 2. Now, is that possible? Also no. Why? Because if V is 2, we cannot get a possible X digit. So we can try V is 3. Now, is V equals 3 possible? Yes, it is. We can get an X value if V equals to 3. So the minimum possible V is 3. And we can put that on our number puzzle. And if V is 3, what would X be equal to? That's right. X can only be equal to 6. And so we can mark that on our number puzzle as well. And what would the final answer be for YWVZ, its smallest possible value? 1930. And we solved this problem. But wait, is there another way we can do it? We have the operation of subtraction here. What can we convert this operation to? Addition. So let's try and convert this equation into addition and see if we can solve as well. So I've converted it here into WXY plus WXW equals YWVZ. And let's repeat the process. Where should we analyze first? If you said thousands digit here, I agree as well. And how do we know that the thousands digit is the easiest to analyze? Because two 3-digit numbers added to each other to get a 4-digit number, the thousands digit can only be 1. So we know for sure that Y is equal to 1, and we can mark that on the number puzzle. Now, where should we continue our analysis next? If you said again the hundredths digit, you would be correct. Why the hundredths digit? Well, because we have the same letter of W repeated 3 times. Now, what two situations do we have here? Of course, we have no carryover from the tens and carryover from the tens. So let's consider the no carryover situation first. If there's no carryover, we have W plus W getting the digit of W. Now, is there any W that could satisfy this condition? If you tried all the digits from 0 to 9, you would find that no, there's no W to satisfy this. But not to worry, let's consider the carryover situation. If we have carryover, we could express this as W plus 1 for the carryover, getting the digit W. Now, is there a W that can satisfy this condition? Yes, if you try all the digits from 0 to 9, you'll find that only W equals to 9 satisfies this condition. And so this works. We have found our W and we can mark it on our number puzzle. And what's more, since we know there's carryover from tens to hundreds, we can mark that on our number puzzle as well. Now next, where do we analyze? If you said ones position, I would agree with you. Why? Because we have Y is 1 and W is 9 already. So we have 1 plus 9 equals to 10. And so, can we determine what Z is equal to for sure? Yes, Z would have to be equal to 0. So, we can mark that on our number puzzle. And since 1 plus 9 is 10, we can also mark that there's carryover from ones to the tens position. And now again, we are left with the tens digit last. So, we know there's carryover from ones to tens and from tens to hundreds. So, we can analyze, or rather, we can put this as x plus 1, getting the digit V. And between x and V, which digit should we analyze first? Again, we should analyze V, because we are trying to find the smallest possible YWVZ. So, can V be equal to 0 or 1? Again, no, since 0 and 1 are already used for Z and Y. So, what about V is 2? Is V2 possible? No. And why is that? Because we know v must equal to an odd number. Why? Well, because we have x plus x, the same number, added to 1 from the carryover. So we know therefore that v must be an odd number. So the next possible value is 3. And is v equals to 3 possible? Are there any issues? Well, no issues, so it is possible. So our v minimum is 3, and we can mark that. And if v is 3, what would x be equal to? Now you might be tempted to say x is 1, but is that possible? No, since y is already 1. And what's more, we have carry over from the tens to the hundreds. So we know x needs to be bigger than 1. So what is the other possible x? Only 6 is possible. So let's mark x equals 6. And do we have now a smallest possible YWVZ? Yes, of course, it's 1930. The same as the subtraction method. So, which one did you prefer or find it easier? You can use that one the next time you see a subtraction number puzzle. Let's summarize everything we've learned today. So today we learned about places of analysis. And do you remember what is the first place of analysis we did? The thousands position, or in other words, the greatest value digit. And why did we start there? Well, because in our case, we could determine it straight away. We know for sure that that number is 1 in our particular case. And in general, because there is no bigger value to affect the greater value digit, it is typically easier to start from there. Now, after the thousands digit, where did we continue next? The hundreds digit. And what was special about that? We had the same letter of W repeated. And that's another place we can analyze these kinds of puzzles easier. Now, after hundreds, we move to the ones digit. And do you remember what was particular about the ones digit? Yes, of course. There were already specific numbers. So, that's another place we can analyze to make it easier. And lastly, the ones digit in particular is another good place since there's no smaller possible digit to the right to affect the ones digit. Now, today we had a subtraction problem, subtraction number puzzle. What did we do to the subtraction number puzzle to possibly make it easier for us? We changed it or converted it to addition. So that's what you can do if you find it easier to solve in the addition way. It is up to you. And now you're fully prepared to solve any number puzzle problem. Thank you for watching today. If you have any questions and want to contact me, you can scan the QR code on the left to contact me via WhatsApp, or scan the QR code on the right to join our Primary 4 study group. Thank you for watching. See you in the next video!